Hi, my friends, welcome back. Let's continue our laser galvanometer motion controller learning. In this video, let's see galvanometer axis interfaces at first. This shows terminals, 15 terminals, and right describes each terminal's meaning. Each galvanometer channel has 2 terminals. When a type is 21, local axis 4 or 5 can be set as the first one, and the local axis 6 or 7 can be set as the second one. Please note these axis numbers are default. If needs to change, use axis address command. The axis type mode can't be wrong. If it is not 21, it will report error. For example, use galvanometer axis 4. The corresponding axis number is 4 and 5, and set the type as 21. Then set some basic parameters. That's okay. For the MC420 scan, out 0 to 7 has precision output function. This precision output function brings high response for move OP. Therefore, it can be opened in high precision control through axis ZSET. If delay precision is required, using move OP delay. Generally, laser doesn't need delay, but dispensing needs it sometimes. Axis ZSET only opens one axis once, and for master axis, it is opened by the value of bit 1 is 1. For encoder function axis, set bit 4 as 1. If the axis is not with encoder, use DPass for precision output. When we set, use below 1. When we read, use upper 1. Actually, there is another command to open precision output. System Z set, which is usually used before. Their setting methods are the same, but when this is changed, this also will be changed. And it is not for one axis. All outputs support precision will become precision mode. Therefore, it is recommended to use axis Z set. Please see the example. 0 means axis 0. 19 means that bit 4 is 1 and bit 2 is 1 and bit 0 is 1. If encoder is not brought, bit 2 is 1, that is 2. At this time, precision mode takes effect, and we use move OP, the response time becomes much faster. Okay, now we learned basic knowledge. Let's learn clearly from one galvanometer marking routine. Here, process 25 arcs, from here to here, then back to origin. It will go an empty segment, then arrive here. It opens laser, then go the arc in anti-clockwise. When the arc is completed, the laser is off and back to starting position. Then go to next marking position, open laser again. The same process, cycle all the time, until 25 arcs all are finished. Now, see the codes. The first one galvanometer axis interface is connected, so there are 4 and 5. Configure as the galvanometer type. Then set basic parameters. Speed is the marking speed. Open continuous interpolation. Set trajectory look ahead mode. Corner deceleration, small circle speed limit and chamfer are on. And set exact look ahead parameters. Then, open precision output. Set frequency. 2 is the actual laser wiring. Please refer to actual wiring and laser manual. No need delay, so set it as 0. Then use one while loop to mark. Use if to judge the condition. Select axis. Set duty cycle. These are preparations. Then clear and mark. 0 to 4 there are 5 lines arc. When each line arc is completed, move down 15 units. Then mark the second line. This 4 means each line marks 5 arcs, and their interval is 15. Then, it arrives the position to mark. Open laser, move 1 arc. Here judges whether the motion completes. If yes, it will close the laser, and back to the former, mark the second, the third arc. When all arcs are marked, it moves to origin. Now, the whole marking is over. Next, let's see routine displaying in develop. Here is the full codes. Then, connect to simulator. Open the oscilloscope. Configure relative parameters. 3 channels. Channels are these: galvanometer axis 4 and axis 5D pass, and axis 0 OP. Then, select continuous acquisition. OK, click Start. Download. Enter the running condition. Now, it starts to capture and execute the marking. It also can be switched into XY mode. Completed, trajectory stops, and it is at position 0. Enter the condition again, it will run again. Speed is bigger in actual applications. Modify it. Download the program. Input the condition. It can be seen the speed is faster, and the marking is completed rapidly. OK, now the display is over, and the knowledge about galvanometer motion controller is over also. Thank you for your watching. See you next time.